Delete in heap. How do you delete an element that is already present in a heap? So generally, whenever you say that you want to delete an element from a heap, you don't want to delete any random element from a heap. Mostly, you would want to delete the root from the heap. Why is it so? Why is it that you would mostly want to delete the root from the heap? Because a heap will either be a max heap or a min heap. These are the only possibilities. In either case, root is the only element of significance because other nodes in the heap, they don't follow any particular order or something. The only thing is it follows the heap property, which says parent will always be larger than its children. Because of this, root has a significance that root is always the largest element of this complete lot if it is a max heap, and it is the smallest element of this complete set if it is a min heap. So root always have that significance, and what you would want to do generally is that if it is a max heap, you would want to fetch the maximum element and then reheapify. So this is what you generally want to do. So what we will do is we'll first see how to delete root node from a heap, and then we'll also see what if it is a random node and not just the root node. Okay, so we'll start with deleting the root node. So how do you delete the root node off? If you remove this off, then the whole structure will be dismantled. So you should not remove the root node off. You have to keep root node there. So what you will do is you will change the value at the root node. Whatever is the previous value, you will fetch that value and you will substitute that with the value of the last node of the heap. Whatever is the last node of the heap, you will take the value from there, you will put it in the root. Once you substitute it, you will remove off the last node. This is removed off. This is what you will do in order to delete an element from a heap. So that is deleting the root from the heap. So this is the procedure. Then the question is, after you put the last element on the root, heap structure is surely disturbed because whatever was your last element, that is surely not the largest element in the heap. So because of that, when you put that small element on top, your heap property is no more valid. So what do you have to do? You have to reheapify this heap. And for that, you can use the heapify algorithm that we learned. How do you use that heapify algorithm? There are two things that you had to do. You had to check before applying heapify. First thing, what is it that we discussed? You should always check two conditions before applying heapify. First condition is that you should always apply heapify on the root. So yes, you are going to apply on the root. What is the second condition? Both the left subtree as well as the right subtree should already be heaps. So in this case, left subtree, this is not disturbed at all. Whatever was previously there, the same left subtree is there. So you already know this is following heap property. What about the right subtree? It is also following the heap property because it was previously itself a heap and only you removed the last element, which won't disturb the heap property. So you know that both the left subtree as well as the right subtree of root are following heap property, which means both the conditions are satisfied. You can apply max heapify on your root. So what happens when you apply max heapify on root? You will check with the root with both its children. If either of the children are larger than the root, you will swap root with that child. Then you will again apply max heapify on that wherever you have swapped. With that, you will again apply max heapify. So you will check this with both its children. If the parent is larger, you will do nothing. But if the children have a larger value, you will again swap. So this is how max heapify is done. So what we'll do, we'll take an example and understand how to delete the root node. So if this is the tree 80, so this is the same tree we use for insertion. So I want to show you how deletion happens on the same tree. 74, 32, then you had 63 and 50 as children of 74, and as children of 32 you had 15 and 21. Let us say I want to remove the root, that is 80. See, as of now this is following heap property. 80 is larger than 74 and 32, 74 is larger than 63 and 50, and 32 is larger than 15 and 21. So it is following heap property. This is a max heap. What I want to do, I want to remove the root from this max heap. So I'll remove 80 off. That is, I'll change the value 80 and substitute it with the value of last node. So what is my last node? Last node is 21. So I'll substitute 21 here and then I'll remove 21 off. So that last node is removed off. After this, at this point if you see, it is no more a heap because 21 is not larger than 74 and 32. It is smaller, which means heap property is violated. So I'll apply max heapify algorithm. So for max heapify, what are the conditions? Left subtree, it should be a heap. Yes, it is a heap. The right subtree, it should be a heap. That is also a heap, which means I can apply max heapify. I'll compare 21 with its children, 74 and 32. What happens then? 74 is the largest among 21, 74 and 32, which means I have to swap 21 with 74. So I'll swap 21, I'll put here, 74 will go up. What is the next step? I have to again do on this. I'll check 21 with 63 and 50. What happens then? 63 is the largest among 21, 63 and 50. So I'll swap 21 and 63. So 63 will come here, up, 21 will go down. At this point, 21, that is the element under consideration, that is already reached the bottommost point, that is the leaf point. After this, I can stop. So at what point can I stop? I can stop either when it reaches the leaf or if I reach a point where parent is already larger than both its children. So that is the condition. So all these are considering max heap, okay? So this is the procedure we have to follow if you want to delete. What we'll do, we'll write the pseudocode and then let's understand time and space complexities of this algorithm. So this is delete algorithm. How do you delete off? Delete. I have a heap, so delete from a heap. Let us say heap is my input. What do I have to do? The first thing, see, whenever you want to delete from anything, always do this check whether it is empty. Because if it is an empty heap, you can't remove anything. So always, whenever you have a deletion operation, you always should make an empty check. That is, if the heap is empty, if not heap. That is, if the heap is empty, then what you should do? You should return something like -1 or something, which says deletion is not possible, okay? That is, in case heap is empty, this is how you handle. So once it crosses this point, you know heap is not empty. There is some value in the heap. So then what can you do? You can remove the root, then you have to replace with the last element and then, sorry, you can't remove the root. You have to replace the root with the last element and then remove the last element and then apply heapify. So first thing is replace root with last element, right? You have to replace root with the last element, whatever it be. This is the first thing that we did. After you replace root with the last element, what do you have to do? You had to remove the last element. So next step is remove last element. So after you remove the last element, what is the next thing? So now whatever is your last element that is gone, that is at the root, and the root is now violating heap property. In this case, you want to do a max heapify. So how do you max heapify? I'm not repeating max heapify pseudocode here because that will be a repetition. In the heapify lecture, we already wrote the complete pseudocode for max heapify. So I'll simply write as a function max heapify. You have to apply on the heap and you have to apply it on the root of the heap, on the root, and the size of heap is, let us say, n. So this is what you have to do. So this algorithm looks very simple because max heapify part I have not described in specific because we already covered it in the heapify lecture. So for deletion, these are the steps. First thing is you have to do an empty check whether the heap is already empty. Then you have to replace the root with the last element. Then you have to remove the last element and then you have to apply max heapify on the root of the heap. That is, the last element is presently at the root. On that, when you apply max heapify, the whole thing is converted back to a heap. So we saw that in the example that we used. So what are the time and space complexities here? So if you see the time complexity, this replacement, it is order of 1. It is a constant operation. Removing last element is also order of 1 operation. What about the max heapify? Max heapify, we already know it is order of log n, because log n is the maximum height possible for a heap. So it depends on the height of the heap, and max heapify is of order of log n. So your time complexity will be order of log n in this case. What about space complexity? This algorithm, as you see, is not taking any extra space. Then the space only depends on max heapify. So max heapify, if you are using recursive algorithm, it takes order of log n. If you are using iterative algorithm, it takes order of 1. So this is applicable for all the algorithms that we discussed, that whenever you are using a recursive algorithm which calls itself for the number of times of the height of the heap, it will be order of log n space complexity because of the recursion stack. But in case of iterative algorithm, you can get it at order of 1 space complexity because you don't have to use recursion stack because you are not using recursion. So this is about time and space complexity. Next thing is, we said we'll also discuss about what if you want to delete a random node and not just the root of the heap. So if I want to delete a random node, then what should I do? So if this is the heap that I have, I want to delete this node, let us say, then what should I do? You have to use the same logic, but you just have to modify it according to the situation, because previously what did you do? When you wanted to remove the root, you substituted with the last element of the heap. So this time, when you want to remove this node, what you have to do? You have to consider only the subtree which is having this element as the root. So take the subtree which is having the element to be deleted as the root. Then do the same procedure that we did presently. That is, consider the last node of that subtree. Don't take the last node of the complete heap. Take the last node of that subtree, then substitute the value of last node of the subtree on the node to be deleted. Thereafter, you can remove off the last node of that subtree and then do max heapify only on that subtree. Don't do on the main root of the tree, do only on the subtree. So the logic remains the same as the deletion of root, but whatever we did on the total heap, you have to do only on the subtree which is corresponding to the node to be deleted. So this is the deletion algorithm in a heap.